Okay, this is Math 2. We're going to do 36 to 39. And for the first one, it says Coach Danielle recorded a 5K race. He is hoping to use the information to establish the team goals for the coming season. And then it goes through and he basically gets the data from all of his players. And then he's trying to actually find an equation that best matches the data. And what we have here is a couple of, there's a scatter plot for all of his players. And here's your equations, 1, 2, 3. So the question is, which type of the equation do we have for each one of the three? So on the first one, it's y equals 16.0. The second one is 0.00566x squared. The third one is, 24.0. And then hopefully you can see which one's which. So first of all, just looking at the three of them, the most obvious one should be the linear one. So in this case, the third one would be your linear equation. Linear function, or linear equation for that matter, the third one. And then the second one has an x squared, so that will be your quadratic equation. And then the first one is to the x power, so that's your exponential. And then the second question was, explain to Coach Danielle which model you believe is the best and why. So looking at this, I was like, okay, well, first of all, I'm going to throw out the linear one because it's not even, I mean, it's pretty good okay as a representation maybe over here in the cluster, but realistically it's not hitting this range up here or these clusters down here, and then it's definitely not hitting anything down here. So I'm going to throw out the linear function. So the third one is not a very good model to use for the scatter plot. And then you looked at the first and the second one, I'm like, well, they kind of both look about the same, but then I started to notice, oh, wait a minute, here we go. If this is a quadratic, that's pretty much means that somewhere here, it's actually going to start to rise up again. So when you really think about the data, you're really not going to have anything start to come back up again once your players sort of kind of peak over here in runtime. Then a quadratic, which will actually kind of sort of go up in this direction again, is not really the best model because technically your scatter plot for the exponential means your information, as your players get better, their runtime is really just going to start to flatline a little bit. So the exponential function is actually a better model to use for the players. And then use the model you chose in part B. In this case, I guess I chose the exponential one to predict the 5K time for athletes who train 10, 20, and 30 kilometers a week. Show how you know. So X was actually your time, if I'm not mistaken. For each equation, X represents the number of kilometers. The number of kilometers run in the training during the previous week. Y represents the race times. Okay, so it's actually backwards than what we're used to. So in this case, X is going to be the number of kilometers, and then Y is going to be your time. So if you run 10 kilometers, let's see how fast you're going to be. So if you run 10 kilometers, where's my black pen? You run 10 kilometers. So let's see, we have, I'm going to work over here. So we want to run 10 kilometers, right? So 10 kilometers is going to get replaced in for the X. So Y equals 16.0 plus 10 times 0.95 to the 10th power. So 16 plus 10 times, what's 0.95 to the 10th power? 0.95 to the 0.59 to the 10th. Is going to be, okay, 0.5987, 0.5987. Okay, so I'm just going to multiply this by 10, and then I'm going to add 16 to it. So 21.98. So Y is going to be 29. Whoa, wow. That was horrible. 21.9. 8. Well, 21.99. I'm going to round because I'm pretty sure we're going to do this in 21.99. Is this seconds? In minutes. Okay, so almost, I'm going to round to almost 22 minutes. So if a player is running so judging by the data, if you run or if you train only on 10 kilometers a week, you're going to run into 22 minutes. And you need to do the same thing for 20, and then you need to do the same thing for 30. So hopefully you should start seeing that, ideally, the more that you train during the week, 20 minutes, or not 20 minutes, if you train for 20 kilometers or 30 kilometers a week, your time should improve, ideally. Okay, and then the last one is, okay, so I guess he determines that if you train for 20 minutes, you should get somewhere around 17.86 kilometers. Or, sorry, if you run under 20 minutes, he determines that X has to be around 17.86 kilometers. So, coach now proudly proclaims that if he makes his athletes run 18 kilometers per week, they should run under 20 minutes in the 5K races. So assuming our arithmetic is correct, explain the flaws in his plan. Well, the flaw in the plan is pretty much, whatever might happen. You have food, you have wind, you have, someone's sick, anything can possibly happen. And I think the book said something along the lines of, there are many variables that could be a source of a faster 5K race times tied to training and distance. Training distance like age, experience, equipment. I guess gender is a factor. I don't know why that would be a factor, but I guess so. So anything can happen. But presumably if you train more, you should get better at running. All right, that was 36. There was really no math involved with Part D. Just give me your opinion. All right, 37. Multiply each of the following expressions. So I'm going to do, I'm going to set you up for B. A is pretty much the same thing as B. But the setup would be, okay, you're multiplying. So my advice is to create an area model. So we have X plus 2I, and then we have X minus 2I. That gives us, let's see, X squared. And then we have, okay, negative 2xi, because we're multiplying everything together. And this is positive 2xi, because we're multiplying these two together. Negative 2 times positive 2 is negative 4. I times I is just I squared. And to clean this up, because that's technically what we're trying to do, is to simplify it out, even though it doesn't say that. Sorry, that's a blob, not a minus. We have x squared plus xi, so plus 2xi minus 2xi. So that pretty much cancels each other out because they're both the same. One's positive, one's negative. So there's a zero pair right there, and we're left with negative 4i squared. Well, that's x squared, negative 4. I squared, if you don't remember, was negative 1. Hopefully you remember that. I was the square root of negative 1, which didn't really help us, but I squared was negative 1. And then you're left with, as a final result, x squared plus 4. Okay, so taking this idea, the next question is write the expression x squared plus 25 as a product. So meaning how could you break this apart, or how can you factor this? And realistically, this part B was your clue, because now you have x squared plus 4, and it came from x plus 2i, x minus 2i. So if you take the square root of 4, which is 2, or in this case, if you're solving, really it's the square root of plus 2 minus 2, because either negative 2 or positive 2, when you square either of those, you should get a 4. So technically, as an expression, as a product, x squared plus 25 should be something like x plus 5i and x minus 5i. And you can actually check it. If you do the product, x plus 5i, x minus 5i, and work it out, you should get, hopefully, the x squared plus 25, because you'll have a 0 pair down the diagonal, and then negative 5i times positive 5i gives you negative 25i squared, but I squared is 21, so you're pretty much back at as the work that you did in part B. Okay, so that's 37, and then you should be able to handle 37a by yourself. I remember negative 1, if you're not comfortable with this, you're more than welcome to put a 1 and a negative 1 up there if you want to. Okay, 38. In ABC, or triangle ABC, measure of angle C is 90 degrees. Okay, AB is 10. Sine of A is 0.5. Okay, I'm going to draw a picture because this will probably help a little bit better. Okay, okay, so C is the 90-degree angle. I'm assuming this is A. All right, well, we'll see what happens. I don't think it's going to go wrong, but we'll see what happens. All right, so C is 90 degrees. AB is 10, so AB is 10. Sine of A, or this angle up here, right? This is the angle right there. There's sine of A, is 0.5. So, okay, let's see how I'm going to do this. So that means sine of A is the same as 1 over 2. Okay, so 0.5 is just 1 over 2. So that should help, because if sine of A is 1 over 2, then if we look over here, we should be able to determine the rest of this information. Sine is opposite. Opposite is CB, which is this part down here. So let's say this was X. I don't know, for the lack of a better word, it would be X. So if sine of A, which is opposite over hypotenuse, is 1 over 2, and we know this for a fact, then what does the number here have to be? When we simplify it, we get 1 over 2. So let's see. Well, you can take a guess, obviously, but the best way to do it is, all right, well, let's say it's 6, right? 6 over 10 would be not 1/2. That's more like, 3 over 5. Okay, so that's not going to work out. So let's say it's, 4. 4 over 10. Well, 4 over 10 is still not 1/2. Okay, so it's definitely not 4. So let's try 5. 5 over 10. Okay, well, there it is. Sine of A is 5 over 10, which is the same as 1 over 2. So technically, this side CB has to be 5 because there's no other option where sine of A has to be 1 over 2. So if CB is 5, okay, that takes care of that. What is the measure of angle A? All right, no problem. Well, sine of A is 1/2. So that means inverse, or sine A, or angle A, I should say, maybe we can say it as angle A, has to be the inverse of 1 over 2. And if I'm going to punch this into my calculator, because there's no way I'm going to do that in my head, inverse sine of 1 divided by 2 is going to be 30 degrees. Okay, so angle A is 30 degrees, or the measure of angle A is going to be 30 degrees. Okay, so that's, I guess we could take that to the bank, so that's 30 degrees. BC is 5. Okay, well, I guess we figured that one out earlier. Cosine of B. So this is cosine of B. So that's 30 degrees. This is angle B down here. So cosine of B is adjacent over hypotenuse. So it's really 5 over 10 again, better known as 1 over 2. So cosine of B is really equal to 1 over 2. Okay, well, that works out. And then lastly, AC. So you pretty much can do AC any which way you want. If you want to use Pythagorean theorem, you're more than welcome to. Otherwise, you can use a different setup. I'm going to let you figure out what the side length AC is by yourself. And then 39, which number below could be the length of the third side of a triangle with the sides of 29 and 51. Okay, so let's see. There's a couple ways to do this, so I'm going to try to figure out which way. Either we add them up or we subtract them. So which way do I want to do this? Well, I guess we could figure this out. Okay, so let's say you had 10 and 29 and 51. Let's say you had those three. Okay, well, does this work out? The small one plus the medium one has to be, when you add them up, the rule was, when you add them up, it has to be more than the third side. So is 10 plus 29 more than 51? Okay, so let's see. 10 plus 29 is 39. 39 is not more than 51. Okay, so A is out of the picture. Okay, let's say it's 18, 29, and 51. Okay, well, 18 and 29 are the shorter sides, so 51 is the largest. Is 18 plus 29 more than 51? Okay, so let's see. 18 plus 29 is 47. 47 is not more than 51. Okay, so 18 is out of the picture. I don't know. Let's go for a really big one. Let's go with D. I don't know. It could be C or D for that matter. I don't think it said there's only one. Oh, it is say multiple choice. Okay, let's try D. Let's see. 81, 29, and 51. Okay, well now 81 and 29 are no longer, obviously, the smallest sides. Now the small side is 51 and 29. So is 29 plus 51 going to be more than 81? That's your question. So we have, what is that, 0, carry the 1. 80 is not more than 81. Okay, so that's false. Sorry, I meant to write false, not true. I don't know why I said that. 80 is not more than 81. Okay, so that throws that one out. So hopefully it's C. So 23 plus 29 and 51. So 23, 29, and 51. 23 plus 29, because those are the smallest ones. Is that more than 51? That's a 2. And then carry the 1. So that's 52 is more than 51. Yes. Okay. So the only possible option, if something, what could be the length of the third side, would be have to be 23, because the others don't follow the pattern of the inequality for sides of a triangle. Okay, and then 30, I don't remember what I said I was going to stop at. Oh, 39, I was stopping here. All right, we shall continue in the next video.